Hey guys, let's knock out this last review before Christmas break. That's awesome. Okay, the first two just say describe the transformation represented by G. It didn't even ask you to graph, so that +3 is inside, so I'm saying that's a shift to the left by 3. Remember, opposite of what you think inside. Second one's got a couple things. It's got a 1/4 in the very front, which means there's a vertical shrink by a factor of 1/4. Let's say by 1/4. And then it's going to shift down 3 because that 3 is outside. It's not inside of parentheses with the cube. All right. Number 3, write a rule for G. Describe the graph as a transformation. So we got a couple things going on here. We got an x minus 2, which means we got to shift to the right by 2. And also we have a vertical stretch by 3. Okay, so to do the x minus 2, what I'm going to do is I'm going to substitute an x minus 2 everywhere there's an x in the parentheses. That's going to shift everything to the right. But then also have that 3 that's a vertical stretch. So what I also must do is multiply everything in there by 3. So we're just going to do this. We're going to leave the 3 in the front here and multiply everything through by 3. We're just going to leave all the parentheses there, and that's fine. That's good enough right there. So make sure you do both things. Number 4, graph these. Okay, now we need, first of all, count how many zeros we have. That's x squared, that's 2. There's one more, that's 4 altogether, which means it's even. So the ends of my graph are going up. Let's pop the zeros. 1 0 is at +2, that came from there. 1's from -1, it came from there. And 1's at -3, it came from there. Now, that -2, the +2 rather, has a square, which means it's going to bounce there, but the rest of them are going to pass through. And because it's even and positive, both ends are going up. So it's going to go through there. It's going to bounce off there and go right back up. So it looks something like that. And we're not going into exact points other than the intercepts and also the end behavior. The second one here, 1 0 is 0 because that x is sitting outside. Right here, that's a -2 that comes out of there, and a +3 comes out of there. There are 5 total x's, which means, and it's positive in the front, which means it's going down to the left and up to the right. That's what I'm looking for. It's going to bounce twice off the -2 and the -3. So it starts down here. It's going to bounce off the -3, come back up through the 0, bounce off the, I got that backwards. Bounce off the -2. Sorry, bounce off the -2, go through the 0, bounce off the +3, and go like that. Some semblance of that graph right there will be perfect. All right, let's go to number 6. Number 6, find all the row zeros. We've done this a lot now. We can start by making a list. Factors of the last over factors of the first. Factors of 2 are 1 and 2. The factors of 4 are 1, 2, and 4. So I'm going to put 1, 2, and 4 over 1. Then I'm going to put 1 over 2. 2 over 2 is already there. 4 over 2 is already there, so that's my list. I'm going to get my calculator, punch them in, look for x-intercepts. All right, looks like there's one possibly at -4. I mean, you got to prove these. So I'm putting -4 in my box. Going to do synthetic, and this is 0. Remember, I will get 0 from my remainder. So I'll put a 2 down here, bring the 2 down, multiply, add, multiply, add. Yep, it is. So that leaves me 3 numbers, which is what I always like. Because I started with x cubed, these numbers down here represent 2x squared minus 1x minus 1. I'm just going to solve that. I'm going to try slide, divide, slide. So I'm going to slide the 2 over there. Factor it. Okay, that's the slide part. Don't forget to divide. All right, we slid the 2. Now we got to divide by 2. And that's really all I need to know. That right there, that factor, gives me an answer of -1/2. And I'm looking at my calculator. It looks like it does cross at -1/2. That right there, 2 over 2 is 1. So one answer is 1. And don't forget the answer we found first, which is a -4. And there you go. Those are all the real zeros, meaning there's no i's. Number 7, to find the x-intercepts and points where max and mins occur, and then increasing, decreasing. That's a lot of stuff. That's a lot for one problem. Because it's x to the 5th power, it could have 5 x-intercepts, and it could have as many as 4 max and mins. That'll be where it also increases and decreases. So take a second, let's punch this in the calc. All right, and this is what we did where you have to solve on your calculator. Okay, just for you to find the zeros, I'm going second calc 0, which is number 2. It's going left bound, right bound. I'm seeing 3 zeros, left bound, right bound. I'm talking to you while I'm doing my calculator. So one of my zeros is at, one of my x-intercepts is at negative 2.16. That's one of them. The next thing I come to as I'm doing this is there's a max. I'm just going left to right. So I'm going second calc, maximum, left bound, right bound, guess. So the maximum is at negative 1.63 and 10.5. That's a max. Next thing I see is another 0. So I'm going second calc number 2, 0. Left bound, enter, right bound, enter, boom, guess. Okay, another 0 is just at 1. It's pretty convenient. Then I see a min. So I'm going second calc. I'm just going left to right, guys, on my calculator. The minimum, left bound, I'm already there. Right bound, guess. My minimum looks like it's at 1.46 and negative 1.68. That's the minimum. And I got one more 0, so I'm going second calc, 0 again. Left bound, right bound, guess. And I'm getting 1.74 for my last 0. So there's my zeros. That's one of the answers. There's my max and my min. There's another answer. And now I need increasing, decreasing. Okay, that's going to involve these. And when you do increasing, decreasing, you're using x coordinates. So the graph starts off, if I'm looking to the left, it's increasing from forever until it gets to negative, to the max, to 1.63. Then it starts decreasing. Okay, and it decreases from negative 1.63 till it gets to the min, which is 1.46. And then it starts increasing again. So it's increasing from the 1.46 to forever. And that's the last part of that answer. Okay, that's a lot of stuff right there, but it's all on the calculator. If you need help on that, come see me before we take this thing and we'll work it out here. Let me erase what I just did so we have room for number 8. All right, here we go. Number 8, find a function of least degree. Leading coefficient 1, 0 is 3, and 4 minus 2i. Remember, if it has 4 minus 2i, it also has 4 plus 2i. So I'm going to say f of x equals, the 3 came from here, the 4 minus 2i, you do x minus every time. X minus 4 minus 2i, x minus 4 plus 2i. Now, a few steps here. We're going to leave that x minus 3 to the very end. Right? Distribute the negative sign, the inside negative sign. That makes it look like this, x minus 4 plus 2i, and x minus 4 minus 2i. Now, what I need you to see here is, well, let's do this first. I'm still going to leave the x minus 3, saving that for a while. I need you to see that these two parentheses, the second two parentheses, are conjugates. I have x minus 4 in both of them, and I have a positive 2i and a negative 2i. So what I'm going to do in those parentheses is I'm just going to do foo. All right, so here it goes. I'm going to do x minus 4 times x minus 4, which is x minus 4 squared. I'm going to do positive 2i times negative 2i, which is negative 4i squared. All right, now, still save that x minus 3 for a minute. I'm going to multiply out this stuff in the brackets. This one I'm going square, multiply double, square. Now that I squared, don't forget I squared is really negative 1. That changes that minus 4 to a plus 4. So I'm going to write it. You don't have to write this line. I'm going to so you can see what I'm doing. I'm going to add the 16 plus 4, which is 20. And I'm finally to a point where I can now involve the x minus 3. I'm going to take the x all the way through first. X times x squared, x times 8x, x times 20. And now I'm going to take the negative 3 through. Negative 3x squared plus 24x minus 60. And I'm going to see what I got left. We'll see what I can add together, So I got x cubed. I can add those two. That's a negative 11x squared. I can add the x's, which is 44x. And I got the minus 60 at the end. That was a lot of stuff. Lots of work there. All right, number 9. I'm erasing this, so I'll do number 9. Number 9, how many positive, negatives, and imaginary are there? Okay, let's do positive first. First of all, don't forget your degree is 5. That's a big deal. It means I'm going to have 5 altogether. So positive, I'm just counting sign changes. It starts positive, it changes to negative, changes back to positive. So there's 2. And don't forget, if there's 2, you always put 2 or 0. Only time you don't subtract 2 is if you start off with 1 or you don't get any. Okay, to find out how many negatives there are, I'm going to change the signs of the odd exponent. So it's going to be negative x to the 5th plus 2x cubed plus 8x. Those all have odd exponents. Never change the sign on the constant term at the end. I'm going to count sign changes again. And when I count sign changes now, I'm looking at just one sign change. Okay, so that's all the negatives. So imaginary is whatever's left. Because I have to have 5 altogether, if I have 2 positives and 1 negative, that means I must have 2 imaginary. The other case is I may have no positives and 1 negative, which means I need 4 imaginaries because I got to have 5 altogether. Your imaginary line, remember, will always be even. If you don't get even numbers down there, you know you messed up somewhere. Last slide. Number 10, solve these by elimination. I'm just going to go right now. The y's are ready to go. All right, so I'm going to like draw a line right here and just add stuff up. There's nothing to add to the 3x squared. The x's would be 1x. Negative 5 plus 2 is negative 3. And the y's, gone, which is what I wanted to happen. And I'm looking at that right there like, man, I got to solve that. I'm thinking about slide, divide, slide, but you know what? That's not going to work. Which means I'm going to have to do quadratic formula. So we're going to x equals negative b plus or minus the square root b squared minus 4ac all over 2a, which is negative 3. Okay, so when I start working this out, I'll get negative 1. Let's see, 4 times 3 is 12 times 2 is 36. Oh, man, it's going to be negative 35 in there. And because it's a negative 35, I would have to pull out an I. And here's the deal. When you're solving a system, all right, you're looking for where this graph would intersect that graph. And if you're getting an I, I's are on the graph, if you know what I'm talking about. Like they're not going to intersect. So this one, solve the system using elimination, there is no solution to that one. I would not expect that tomorrow, but you never know. But I don't think it'll be no solution tomorrow. And I think you'll probably be able to factor that one. Number 11, last one. Let's graph this inequality. First of all, we're going to graph it like it says this, like it says y equals negative x squared plus 2. Because there's an x squared, you know it's a parabola. The negative in the front means it's been reflected across the x-axis. The 2 means it's going up 2, so I'm going up 2 to right there. Normally I go over 1, up 1, but this time I'm going over 1, down 1, over 1, down 1. Now, don't forget to do this part. Ask yourself, because it's got this sign in here, is it going to be solid or broken? Because there's an equal sign, it's definitely solid, so I'm going to draw my parabola going down. Now, to finish this one up, you have to shade either inside or outside of your parabola. And remember the point we always pick when we can. We always pick 0, 0. So I'm going to put 0 in for y and also 0 in for x. And that's what I get. I get 0 is greater than 2. You could ask yourself, is that true? Is 0 greater than 2? No. I hope you say no. So that means I'm not going to shade where 0, 0 is, which is inside. I'm going to shade outside because 0, 0 is not inside. And I'm going to get out. That's the answer right there is all that shading. And make sure your parabolas either solid or broken. And you got it. All right, guys. Last review. Well, I shouldn't say that. We're going to review our semester test. But last regular review until January. So do good tomorrow. Last test before Christmas. Do great, great. Come see me if you need me. See you then.